Current automobile chassis are made up of tens or hundreds of individual parts, which are made of many different materials and must be joined together in several different ways: welds, bolts, and adhesives. Tesla's plan is to use two huge single castings for the front and rear underbody sections and to connect them with a battery pack that serves as part of the body structure. This innovation reduces weight and greatly simplifies vehicle assembly. To get a fair idea, take a plastic toy car, for example. The cheaper ones are usually made from a single solid piece before the tires are tacked on. Now imagine the whole chassis of a car made the same way, but this time made from metal. In this video, we'll be unveiling the secrets of how Elon Musk is changing the game in the car-making industry and how this revolutionary technology gives an edge to Tesla over the competition. Let's get started. Cast components are a staple of automotive manufacturing, but the norm is to cast smaller parts, which are then assembled into larger structural elements. As Elon Musk tells the story, one day he was considering a die-cast toy car on his desk and wondered what the practical size limit for a casting would be. After some research, he learned there's really no size limit, and he decided to fabricate the front and rear underbodies of a vehicle as two huge castings with huge machines made by Giga Group. Tesla is a company that's used to doing big things, which makes it not surprising that Gigapresses would be found in their factories. They're huge by all standards and most likely dwarf your apartment. A Gigapress is a die-cast machine among the most powerful ever built, with a capacity of 61 kilonewton clamping forces. They weigh more than 400 tons and require more than 20 flatbed trucks to move only one. They measure 20 meters by 7.5 meters by 6 meters. They're made by the Italian manufacturing group known as Giga, and the company has enjoyed Tesla's patronage more than a few times, with what we heard to be current multiple orders yet to be filled. Interestingly, even though the name Gigapress goes with Tesla's Gigafactory, the name was actually coined by Giga. How Gigapresses work? The Gigapress is more like a die-cast setup than a machine. It's equipped with all sorts of devices and systems required in the die-cast process. The components in Tesla's Gigapress include ovens. The Gigapress uses two sets of ovens for handling the aluminum alloy. One is a melting oven powered by natural gas and operates at 850 degrees centigrade. Another stores the liquid metal heated by electric power and operates between 750 and 850 centigrade. Gigapress. It's the core of the whole setup or the die casting mechanism. It has a similar construction to any regular high-pressure die casting equipment and functions like one, except it's enormous in size. The vacuum tank. The Gigapress uses a 4,000-liter tank for creating a vacuum inside the mold. It's made by Fonderex, a Swiss company that first invented the vacuum technology for high-pressure die casting. A quenching tank. The quenching tank rapidly decreases the temperature of the casting to a desirable limit. It's allowing one to achieve some specific properties for metal casting. A trimming device. There's mechanical trimming presses and laser trim for rapidly cutting the excess metal that's attached to the casting. A scrap metal recycler. This is a recycling system to utilize the scrap metal. The scrap aluminum is shredded and offcuts are utilized for the next casting cycles. Inspection devices. Various inspection devices check the finished casting, such as CMM and X-ray machines. The working principle of the Gigapress can be divided into the following steps. Material preparation. First of all, we have to melt the aluminum ingots and cutoffs from the previous casting cycle in an oven at 850 degrees centigrade. Then remove any impurities from the surface and convey the liquid metal into another enclosed oven using heated pipes. That oven maintains a temperature of about 750 to 850 degrees centigrade. Fill empty space inside the storage oven with nitrogen gas that prevents the formation of oxides in the molten aluminum. It also helps to maintain an even temperature. Additionally, operators use argon gas, rotary degasser, and silicon carbide filters to further remove impurities. Die preparation. Before commencing each cycle, you lubricate the die surfaces. A robot will spray about 35 milliliters of soybean oil into a thin layer to enable easier separation of the castings. Then the vacuum system creates about 50 millibars of vacuum pressure inside the mold cavity. Casting. The molten aluminum is transported from the holding oven to the shot chamber of the Gigapress. Then the molten metal is forced inside the cavity using a high-speed plunger. The plunger is also lubricated using 8 milliliters of oil before each shot. Once injected, the casting is left inside until it solidifies. Then the casting is ejected from the die at 400 degrees centigrade. The raw casting is then placed in the quenching tank to reduce the temperature from 400 to 50 degrees centigrade rapidly. It helps tackle some defects and increase some material properties. Cool the open die to 150 degrees centigrade, thoroughly clean it with robots, and prepare it for the next cycle. The next casting cycle begins usually 1 to 2 minutes after the current one finishes. Finishing. Now you're cutting each of the raw castings into approximate dimensions using a mechanical trim press. The scrap aluminum is recycled with a scrap metal shredder and added back to the oven. Then the main casting is checked with an X-ray to determine whether it has any internal defects. The verified casting is further perfected using laser trim and drilled using a CNC machine for fittings. And finally, you check the finished coating's accuracy with a coordinate measuring machine. Gigapresses require a lot of investment in space for installation, so Tesla must have seen the clear benefits before committing to them. The fact is, the Gigapress is a game changer in the auto industry. The most obvious advantage is speed, because despite their great proportions, they work very fast. Per IDRA specs, the aluminum silicon alloy can go from molten metal to a chassis in less than 100 seconds, and that's a blithering speed when you compare that to all the steps and labor involved in fabricating and fastening more than 100 parts together. It simply means Tesla can make more cars than the rest. Tesla currently has 2 Gigapress machines at the Fremont factory that produces the rear megacast for the Model Y underbody. Drone flyovers in the area suggest that Tesla's Fremont-based Gigapresses have a cycle time of about 170 seconds per casting, likely due to the machines not being fully optimized as yet. If we make some quick math using that cycle time of 4 to 5 minutes and estimate the single factory with 10 Gigapresses running continuous shifts, they could produce 350,000 Tesla Model Y chassis in a year. And that's because the Model Y chassis requires 2 Gigapresses. That figure goes up when the Gigapresses work closer to spec by the maker. That means a new factory could easily make 100,000 units in its first year of production. Such huge numbers are basically unheard of in the automaking world. Benefits of a single-piece casting from a Gigapress? They're lightweight, which translates to more range for the same battery capacity, and cost-efficient, simpler production processes. Gig casting will help achieve a 40% reduction in rear underbody cost savings. Also, the new single-piece casting will deliver a 30% reduction in the size of the body shop. For instance, a single Gigapress makes about 300 robots redundant. There's not much coupling or much lifting work to do. Experts estimate that Tesla could save about 20% on labor cost from the single-piece casting. Using the Gigapress also eliminates alignment problems caused by the combination of several small parts, resulting in higher quality vehicles. Just think about the logistics involved in making more than 100 parts in different locations, monitoring for quality and transporting them to the assembly plant. Tesla is able to avoid all of that with this army of Gigapresses. As Tesla finds new ways to drive down cost, it positions them well ahead towards a more affordable car that many more people can afford. At an estimated U.S. cost of $25,000, that would be affordable by many, many more people. A large die casting machine is expected for the Tesla Cybertruck production. CEO Elon Musk commented it would need an even more powerful, high-pressure die casting machine with a clamping force of 8,000 tons for the production of Cybertruck at Tesla Giga Texas in Austin. That's where construction is still underway. However, the foundation for 3 Gigapresses became apparent by January of 2021. Tesla installed 3 more Gigapresses in its Shanghai factory, also known as Giga Shanghai or Giga Factory 3. Tesla also started preparation work for housing 8 6,100-ton Gigapresses at Giga Berlin. A report from Germany last July hinted that Tesla is actually planning on producing 2 million vehicles per year in the Giga Berlin complex, allowing the electric vehicle maker to command about 16% of the expected electric car market share in Europe. Tesla has been successfully producing trial runs of the Model Y rear chassis. However, we need to be extra careful when handling such a large quantity of aluminum at once. Recently at Gigapress, Tesla's Fremont factory caught fire during production. The Fremont Fire Department stated the cause of the fire was molten aluminum and hydraulic fluid. Okay, I hope you guys had fun and enjoyed this video. And if you did, you gotta destroy that like button for me. I need that YouTube algorithm. And don't forget to subscribe and click that bell.